IP addresses are written down in a decimal format, but to understand how they control the logical separation between networks, it really helps if you think about them the same way that a computer does, and that is in binary. So in this lecture, I'm going to show you how to convert decimal numbers into binary, and that's going to help understand IP addressing as we work through the rest of this section. As humans, we're conditioned to count in decimal. It's how we're taught to do it from a really young age, and we do it now without thinking about it. When we write a number down, for each column in the number, we have got 10 possible choices from 0 through to 9. And every time we add a column to the left, the value is multiplied by 10. And we start with ones as the furthest right column. So let me show you what I mean. So when we write down a number, starting from the right-hand side of a number, we've got the ones there. The next column is the tens. Then we've got the hundreds, then the thousands, then the 10,000s, and so on. So you can see that it's being multiplied by 10 each time we add a column to the left. If we were going to write down the number 236, the way that we do that is starting from the left now. So starting with the 1000s column, how many 1000s can we fit into 236? Well, obviously that's going to be a 0 because 236 is a smaller number than 1000. So we can't fit any 1000s into 236. That leaves us still with 236 left over. Next up, how many 100s can we fit into 236? Well, we can fit 2 100s into 236, and that leaves us with 36 left over. Next up, how many 10s can we fit into the 36 that was left over? We can fit 3 10s into 36. That leaves us with 6 left over. And then how many 1s can we fit into 6? That's obviously 6. So that gives us the number of 236 is how we would write that down. Now, like I said at the start of this lecture, that's completely obvious and intuitive to you. So you're maybe wondering why I'm breaking it down like that. Well, it's because binary is not obvious and intuitive, but it works the same way. So seeing how it works with decimal is then going to help understand and see how it works with binary. So computers don't work in decimal, they work in binary. And electrical impulses are either off or on. So there's only 2 choices, a 0 or a 1. Unlike the 10 choices that we have in decimal, which is 0 through to 9. And every time we write down a number in binary, for each column in the number, we've got 2 possible choices. That's a 0 or a 1, rather than the 0 through to 9 that we had in decimal. And every time we add a column to the left, the value is multiplied by 2, rather than multiplied by 10 as it is in decimal. So looking at the columns in binary now, again, we've got a 1 on the furthest right, the same as it was in decimal. Then we multiply that by 2, so the next is 2. Then we've got 4, then we've got 8. So we just keep multiplying by 2, just doubling it each time. Next would be 16, then 32, then 64, then 128, then 256, then 512, and so on. So you saw how to write down 236 in decimal before. Now let's see how to write 236 in binary. And you can see on the slide here that the number we're going to get in the end is 11101100. So really not intuitive like it is with decimal. But we do it the same way. So rather than seeing how many we can fit in, it's either going to be on or off, 1 or 0. So starting off with 256 here, does 256 fit into 236? Yes or no? Well, no, it doesn't. 236 is a smaller number than 256. So we can fit 0 256s into 236, and that leaves us with still 236 left over. Next up, can we fit 128 into 236 or not? And the answer is yes, so that gives us a 1, and we've got 108 left over, because 236 minus 128 is 108. So next up, does 64 fit into that 108 that was left over or not? Yes, it does. So we put down a 1 and we've got 44 left over because 108 minus 64 is 44. Next up, does 32 fit into the 44 that was left over? Yes, it does. So we have a 1 again and we've got 12 left over now. Next up, does 16 fit into 12 or not? No, it doesn't. So we put a 0 down and we've still got 12 left over. Then does 8 fit into 12 or not? Yes, it does. So that's a 1 and we've got 4 left over. Then does 4 fit into 4? Yes, it does. So we put a 1 down and that leaves us with 0 left over. So obviously the other two digits are going to be a 0 and a 0 because 2 and 1 do not fit into 0. So you can see there that when we've got it written out, that comes out to 111,011,00. That is 236 in binary. As a final check, you should always have 0 left over. So if you get down to the 1 column and you've still got digits left over there, that means that you've made a mistake, so you should go back and do it again. You can also do a final check of your answer as well, where you do add up all of the columns where you've got a 1, add them all together, and that should total up the number you were looking for. So in our example here, we've got a 1 in the 128, a 1 in the 64, a 1 in the 32, in the 8, and in the 4. So if we add up 128 and 64 and 32, add 8, add 4, that equals 236, which was the number that we were looking to calculate. Okay, next up, let's check that you understood that and you can do it. So what is 179 in binary? I'll pause the video here, write down what is 179 in binary, and I'll be back in a second to check that you got it right. Okay, so how did you get on? The easiest way to do it is to get a pen and piece of paper and write the columns down exactly like you see on the slide here, and then just go from left to right as you saw me doing it in the last example. So figuring out 179 in binary, does 256 fit into 179? Yes or no? No, it does not. So we put down a 0 and we've still got 179 left. Then does 128 fit into 179 or not? Yes, it does. So we put down a 1 and we've got 51 left. Then does 64 fit into 51? No, it does not. So we put down a 0 and we've still got 51 left over. Then does 32 fit into 51 or not? Yes, it does. And 51 minus 32 is 19. So we've got 19 left over. Then does 16 fit into 19 or not? Yes, it does. We put down the 1 and we've got 3 left over. Does 8 fit into 3? No, it doesn't. So we put down 0 and we've still got the 3 left over. Does 4 fit into 3? No, it doesn't. So again, we put down 0 and we've still got 3 left over. Then does 2 fit into 3? Yes, it does. So we put down a 1 and we've got 1 left over. And finally, 1 does go into 1. So we put a 1 there and then we've got our 0 left over. So writing down 179 in binary is 10110011. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.